I want to find the arc length of this asteroid. Now, an asteroid sounds like a weird space object, but actually, the graph of this guy looks like a star. In case you didn't know what this graph looks like, don't worry about it. You're looking at it now. It looks like a really cool star. And I want to find the arc length in all four quadrants of this guy all the way around and find the total arc length. I want to point out, I didn't give you bounds here, but notice that there's a cosine and a sine inside x and y, and that usually suggests going all the way around some sort of unit circle where I would go from 0 all the way around to 2 pi. So my bounds go from 0 to 2 pi. That would be the bounds I'm integrating over here. So I'm going to go ahead and set up my integral. Integral from 0 to 2 pi of the square root of the derivative of this guy squared. Well, the derivative of 3 cosine cubed, it would be 9 cosine squared of t, times the derivative of the inside function. It might be helpful to rewrite cosine cubed of t as cosine of t cubed, so that I see that 3 comes down in front. 3 times 3 gives me the 9. The new power ends up being 2, but then chain rule says I take the derivative of this inside function. The derivative of cosine is negative sine of t, and we're going to end up squaring that per the arc length formula. Plus a very similar looking 3 sine cubed. When I take its derivative, I get 9 sine squared t times cosine of t, and this is also being squared. We're going to extend the square root and make sure we put a dt on the very end of this. Okay, let's go ahead and square everything out here. 9 cosine squared t times negative sine, when I square this, gives me 81 cosine to the 4th t sine squared t plus 81 sine to the 4th t cosine squared t, all square rooted, putting a dt at the very end, and still integrating from 0 to 2 pi. But you know, I'm going to pause for a second. Instead of integrating from 0 to 2 pi, I'm going to integrate from 0 to pi over 2. It's going to make my integration a little bit easier, because if I integrate just from 0 to pi over 2, I notice that the shape is the same in all four quadrants. So I'll just integrate from 0 to pi over 2 and multiply my result by 4, rather than have to deal with the fact that sometimes cosine and sine are negative in these quadrants, and that's going to mess up our integral. I'd rather integrate over the quadrant where cosine and sine are both positive, because that's what I want. I want positive results from this integral, and just multiply the whole result by 4 at the very end. Okay, it's time to simplify this a little bit. We can factor out an 81 cosine squared sine squared, because I can't factor out a cosine to the 4th from this guy. But I can pull out sine squared and 81, because those are in both of the terms on the right, and I can only factor out a cosine squared because while I can factor a cosine to the 4th out of this, I can't factor a cosine to the 4th out of this. So here's how my integral is going to simplify. I pull out, I'm going to put a 4 here, I pull out a square root of 81, that's just a 9. I pull out the cosine squared, that's now a cosine of t. I pull out the sine squared, that becomes a sine of t. And I have the square root of something left over. Well, it turns out that something ends up being 1. Here's why. When I pulled out 81 cosine squared sine squared, I was left with cosine squared. When I pulled out 81 sine squared cosine squared, I'm left with over here a plus sine squared. I know I'm running out of room here, but what I have left inside the square root is cosine squared plus sine squared. And cosine squared t plus sine squared t, well, that's better known as 1. So this square root is just square root of 1, which just goes away. And so I'm left with the integral. 4 times 9 is 36. 36 sine t cosine t dt, and I'm integrating from 0 to pi over 2. The integral of 36 sine t cosine t, you could use a u substitution where you say u is equal to sine and du would equal to cosine. But when you integrate this guy, you get 18 sine squared t. Plug in pi over 2, plug in 0, find the difference, and you get sine of pi over 2, which is 1, times 18 ends up being 18, minus what I get when I plug in 0. But the sine of 0 is 0, so I get minus 0 for a final answer of 18.